All right, in this video, we're going to work through the following indefinite integral. It's x times the square root of 5x squared plus 2. And looking at this integral, we can see that it's not it's not one of the basic integrals. It's not just a derivative fact in reverse. It's more complicated than that. So for us in this class, that generally means we're going to try to do it by substitution. And so we're going to pick a value for u. All right. And so uh, good choices for you at the top of the list are things that are inside other parts of the integral. And in here, that looks like it would be this expression here, 5x squared plus 2. Another good choice for you would be things whose derivatives are almost the derivative, are factors of the integral, or the integrand. So the derivative of 5x squared plus 2 would be 10x. And you can see I have an x here. I don't quite have the 10, but that's okay. When I say almost the derivative, what I really mean is that it's the derivative is a constant multiple of that factor. And so that's what we have here. Okay. So the good choices for you are leading us to you pick 5x squared plus 2 as u. And then we're going to run through. And the next thing would be to calculate the du. So take the derivative. That would be 10x. All right, and then dx here. All right, and so looking at my integrand here, I have, I'm going to have to switch every single occurrence of x, right, over to some corresponding version of using the variable u, using these two equations right here, okay? And so the 5x squared plus 2 that's inside, that's a pretty easy switch because that's just going to wind up to be u. All right, and that leaves me with this x and the dx together. And now, obviously, the dx, right, is going to, I'm going to have to use this equation because dx doesn't appear in this equation, right? And so I can see that over here on the right-hand side, I have more than dx. I have the 10, and I have an x and a dx, right? And you can see here I have this x and the dx over here. So that sort of matches this part of the substitutions. And so what I'm going to do is just sort of rearrange this. And you can see I have the x and the dx perfect here, just like I have over on here. That will make things easy to switch. But what I don't have is the 10, okay? The 10 is going to be, though, because it's a constant and doesn't involve an x or a u, it's pretty easy to deal with. What I'm going to do is to multiply both sides of this equation by 1/10. And so you can see I get 1/10 du is equal to x dx. And that's very, very helpful because that's exactly what I need to account for over in this integrand. I need to switch x dx over to some corresponding version using only the variable u, and you can see that's only the only variable that appears over on this side is the u. So now things are lined up pretty well for the switch, right? And so I'm going to go ahead and switch that. So it's going to be the square root of u, and then x dx is going to be 1/10 du. Okay. And so you can see this is a successful substitution. The integral that I had is more complicated than the one I have now with the u's. This one now is a basic integral. And I can just use some of the basic rules to compute that. So the first thing I'm going to do now to compute this, right, is to use the constant multiple rule. I am going to rewrite this as 1/10 times the indefinite integral of the square root of u. That's the first thing that I'm going to do. All right, and then the square root of u, that is really just a power function where the exponent is 1/2. Okay. And so now I'm ready to go to use my basic fact, and that is the power rule, right? Because this is a power function, some variable to a number power. And so the power rule says in order to take the antiderivative of that, I'm going to add 1 to the power. So 1/2 plus 1 is 3/2. And then I'm going to either divide by 3/2 or multiply by the reciprocal of 3/2, which is 2/3. And that's what I'm going to do, especially when the exponent, the thing I have to divide by, is a fraction. You're going to have to do that anyway, so you might as well just go ahead and do it now. All right, and so next up I need to simplify that. 2 goes into itself 1 time. It goes into 10 5 times. So on top, I have 1 times 1. On the bottom, I have 5 times 3, which is 15. All right, and so I have everything simplified out pretty well. There's one last thing to do, and that is to make the back substitution. I want to make sure that I express the indefinite integral in terms of the original variable there, x. Right, and so that's easy enough to do because I know that u is equal to 5x squared plus 2. So the final answer on this problem is 1/15 times 5x squared plus 2 to the 3/2 power plus some constant c.